Hey everybody, welcome back to Skip Uni. Today we're jumping right into Lecture 4, and we're looking at a huge, highly tested OOPs concept, friendship. And no, obviously not the social media kind. We're talking about friend functions and friend classes in C++. Whether you're gearing up for a brutal university final, a competitive exam, or a really high-stakes placement interview, this explainer is literally built for you. We're going to break this whole thing down with real-life examples so that when an interviewer throws this at you, you don't just survive the question, you totally own it. All right, let's get into it.
Quick roadmap for you today. We'll start with OOPs, strict privacy rules, then move on to bypassing with friendship. After that, we'll hit friend classes and what I call one-way love. Check out the flaw of encapsulation, and finally wrap it up with friend functions explained. Let's go. Starting off with Section 1, OOPs, strict privacy rules.
So to really understand how to break the rules, we first need to know what those rules actually are, right? As you probably remember, a class is basically a blueprint. It holds your attributes, your data, and your methods, your functions. And to keep that data safe, we use access specifiers. You know the ones: private, public, and protected. Now normally, the absolute golden rule of OOPs is this: if a data member is marked as private, it is completely off limits to the outside world. It's locked in a vault. If you're on the outside, you simply can't get in.
But what happens if you really desperately need to get into that vault? That brings us to Section 2, bypassing with friendship.
Under standard access, outside entities are strictly 100% blocked from private and protected members. But here comes the friend concept. It's basically the ultimate VIP pass. It legally bypasses those strict encapsulation rules. If a class declares another entity as a friend, that friend gets special, unrestricted permission to see and use all of its private and protected members. It's kind of like walking up to the bouncer at a super exclusive club and saying, "Hey, I'm with the band," and boom, the velvet rope just opens right up.
Moving on to Section 3, friend class and the concept of one-way love.
Okay, so how do we actually give out this VIP pass? Let's look at the mechanics of a friend class. Imagine we have class X, and it has a heavily guarded private integer, let's say a equals 5. Remember, in C++, if you don't explicitly write private, it just defaults to private anyway. Now, inside the body of class X, you write this super simple yet incredibly powerful line of code, friend class Y. By doing that, class X is explicitly telling the compiler, hey, class Y is my friend. Because of that one single line, class Y can now create a public method, maybe call it show, make an object of class X, and totally access and print that guarded private variable. Class Y literally just reached right into class X's private vault. Now, seeing that interaction, a very logical question pops up. And by the way, interviewers absolutely love to ask this as a trick question to see if you really get it. If class X makes class Y a friend, can class X also access class Y's private members? I mean, think about it for a second. If I give you the keys to my house, do I automatically get the keys to yours?
The answer is a massive, definitive no. And this is exactly what I mean by the one-sided love analogy. Friendship here is strictly a one-way street. Class X considers class Y a friend, so X opened its doors. But unless class Y goes into its own blueprint and explicitly writes friend class X gets absolutely nothing. Y can see all of X's secrets, but X cannot see Y's secrets. Seriously, highlight that in your notes right now because it is a guaranteed lifesaver in technical interviews.
All right, let's jump over to Section 4, the flaw of encapsulation.
So why are interviewers so obsessed with this specific topic? Well, object-oriented programming is built entirely on the foundation of encapsulation. We spend all this time learning how to hide data, secure it, and lock it away from outside interference. But the absolute second you use a friend class or a friend function, you shatter that security. You expose everything. So when an interviewer leans across the table and asks you, what would you consider the biggest flaw or issue in OOPs, this is the exact answer they want. The friend concept legally breaks encapsulation. It is a built-in backdoor, and acknowledging this paradox shows them that you actually understand the architecture on a much deeper level.
Finally, we have Section 5, friend functions explained.
What if you don't want to expose your data to an entire class? I mean, handing over the keys to a whole group of people is pretty risky, right? That's where friend functions come into play. You can be way more precise and grant access to just one specific function. This authorized function can exist in two ways. First, as a global function. This means it's just a standalone function floating out there in your program, completely outside of any class structure. Or second, it could be a specific method. That means it's just one single function belonging to another class, rather than making that entire other class your friend. This setup gives you so much incredible flexibility.
Let's visualize this with some real-life code syntax. Imagine a class called box with a highly guarded private attribute called length. Inside box, we declare friend void show. By doing this, box is basically telling the compiler, hey, there's a function out there called show and I trust it completely. Now, we can create a global function entirely outside of the box class, just called void show. Because we already gave it VIP status, this external global function can easily access and read the private length data of the box class. You can even pass the object into the function by value or by reference, and it reads that private data flawlessly. You have successfully bypassed the privacy wall for just that one specific task. Pretty cool, right?
And that wraps up today's deep dive. Whether you're using a friend class or a friend function, the core takeaway is the same. It gives you, the developer, the power to bypass strict privacy rules when the architecture really demands it. Just remember that one-way friendship rule and the encapsulation paradox for your exams. But before you go fire up your compiler, I'm going to leave you with a quick, provocative thought to ponder. If friendship breaks encapsulation, how would you carefully design a friend function to solve a strict privacy issue in your next C++ project without accidentally exposing your entire system? Really think about that architectural balance. Until next time, keep coding, keep building, and we'll see you in the next explainer.